Okay, so let's see. It is week for Monday. All right, we talked about tidyr on Friday, and we're going to continue on in the tidyverse, and we will discuss dplyr. Dplyr, this might be, so I know like the very first day of class, I talked about like life and stuff, and I said maybe that's the most important lesson. Okay, but today's lesson might be the most important like R related lesson, okay? As far as like data wrangling and stuff. This is probably the like one of the most useful skills that you can develop. And it's not a ton of stuff, but it will take a while to like master it, right? It's kind of like learning the game of like, I don't know, Connect Four, or Othello, or chess or something. It's like, you can learn the rules fairly quickly, but then like getting good and getting fast and quickly seeing things, that takes time and practice. And I, if you're planning on working with data, I recommend investing some time working on these skills. And then on Wednesday, we'll look at regular expressions. That's also a very exciting lecture. Lots of exciting stuff. Oh, okay. Oh, I got to do this. All right. This is the grumpy professor chat. So, we graded homework 1 and we posted those grades, and most of you did well. And, as far as those of you who are attending live, I don't know if this applies to any of you. But it's very important after you knit your document, take the time to read through it before you submit it. Okay, take the time to read through it and find any errors before you submit it. All right, we got a couple regrade submissions, and basically the answer is going to be no if this is what happened. If somebody didn't read in, say, the month names file correctly, right? So maybe there's something went wrong with the working directory or the file name or something, and it didn't get read in, and this is what gets printed, right? I understand when you upload things to Canvas, like it renames files and stuff. Don't worry about that, okay? We're going to look at your PDF, and if this is what's showing up in your PDF, we're not going to give you points for this, okay? We're not going to give you points for this because, like, you should have caught this when you read your stuff before you submit it, okay? And, it's unfortunate. These things do happen. Sometimes I make these mistakes too. But yeah, we can't give you credit for that, right? And I know it's not fun. It's not fun losing points because of something silly like you didn't set your working directory and the file didn't load, right? And that's a silly mistake, and it might cost you a portion on your homework. It might cost you a few percentage points in your final course grade, right? In my opinion, all right, and I know this is my opinion and this is subject, right? I feel like this is a small price to pay, and it's worth this consequence if it reminds you to pay attention to some of these details right before you submit something, right? A lot of times when you're applying for jobs, you're going to see something that says like, we need somebody who's detail oriented, right? And that just sounds like such filler stuff for a job application. It's like, oh, we need somebody who's a team player, and we need someone who's detail oriented or something, right? These are just things that you see like on every job. But a lot of times what this detail oriented stuff means is that a small mistake could end up having large consequences. And they need somebody who's going to double check their own work, or they're triple check their own work before they submit it and send it off, right? Can you imagine just the consequences of a silly mistake, but in kind of a high stakes application? Let's say you're like applying to graduate school and you've written like a personal statement, and you said, for this reason, please accept, I'm excited to apply for, Stanford's data science program, but you send that document to Berkeley or something, right? It's a small mistake, but they're going to look at that and just go and then throw it out. Okay, so just submitting the wrong version, right? It's not uncommon to have like very similar things, but make small different versions, and then if you lose track of those, and if you don't double check or triple check before you submit it, that's like you're throwing that application away. Okay, or what if you email somebody like the wrong person, you CC the wrong person on an email and it's got like confidential information. There was like a whole thing about like somebody entering thing in the public chat versus the private chat and like small details, but then they're like, oh gosh, you know, these things make a difference, right? Or, you know, these are even worse, right? Even like on Venmo, like you type in like someone's username just ever so slightly wrong. It's like, oh gosh, where did your number go, right? So these things make a difference. So don't let silly mistakes, you know, always take the time to double check and triple check. And obviously how much you care is going to be in proportion to maybe the cost of a mistake and stuff. But yeah, a lot of times little details can make a big mistake or make a big difference. So just double check that. Don't let something silly hold you back. Okay, sorry. Thanks for indulging me on my little rant there. Let's talk about dplyr. Okay, so dplyr, core part of the tidyverse. You can load it up calling library dplyr, or you can load all of the tidyverse just by calling library tidyverse, and that will get you access to dplyr. And dplyr is what we use to kind of work through and wrangle and manipulate data. And a lot of times when you do this, the process at a very high level is first you got to figure out what you're going to do. And then you got to figure out how you're going to tell a computer to do this. And then you tell the computer to do this, right? That's about as simple as we can make it. Okay, think and then do. And dplyr, you know, this is taken from the dplyr's own description of itself. So of course it says, hey, we're the best at this. But I truly think dplyr is really great. It gives you a certain set of options, okay, and that kind of limits your what you can do with each step. All right, and so you get these verbs, and these verbs kind of correspond to certain data manipulation tasks, which will help you think about your code, right? It's like you have kind of a set of tools, and this is all you have, and you kind of have to think about your problem in that set. So these are kind of the key verbs that we're going to be looking at. We've got select, and that's going to pick variables. We've got filter, and that's going to pick cases or the rows. You have mutate, which will add new variables. We have arrange, which changes the ordering of the variables. And we have summarize. And what summarize does is it takes multiple rows or multiple values and summarize it down to a single value, right? And all of these things can be paired with a function called group by, which allows you to do any of these operations on a group by group basis. So let's take a look. Oh, before we get into that, here is this cheat sheet. Okay, this is I don't know, a little PDF here, and I highly recommend that you get this and you print this out and you keep it someplace where you can access it easy, and you should study this page regularly until you feel very good about this. Okay, you know, my notes, I think my notes are pretty good, but my notes are also like 50 slides long, 70 slides. You know, my notes have a lot of things, right? So it's a lot handier having just like one piece of paper. It might be microscopic and not a lot of detail, but as far as a reference goes, cheat sheets are great. Okay, so let's do this. Let's do an example here, right? And we're going to use the Star Wars data set. And this data set's now close to 10 years old now. So, but it has information about the Star Wars characters from the first 7 Star Wars movies, all right? And I know they released a whole bunch of movies, but this is like right after they did the, whatever, the newest trilogy, okay? So it was after The Force Awakens, before, what was it? The Last Jedi and Rise of Skywalker or something, okay? And I don't know how you guys feel about the different trilogies, and, you know, I'm probably an original trilogy fan, but, you know, there's the prequel trilogy and the, whatever the third one. Okay, so anyway, this is just the first 7. There's 9 Star Wars movies plus the spin-offs, what, Solo and Rogue One. But anyway, information about this. So we got 87 characters, 14 columns, and it's just got information, right? So I don't know what order this is in, but we got Luke Skywalker. We've got their height in centimeters and their mass in kilograms. Luke Skywalker has blonde hair, fair colored skin, blue colored eyes, was born in the year 19, which is years before the Battle of Yavin, which is when the Death Star blew. We're getting into the Star Wars lore here, okay? And oh, sorry, the Death Star blew up. That's a spoiler there. But if you didn't know that by now, you know, whatever. All right. Okay. And then we've got the species and the home world. And, you know, as far as a dusty planet that nobody cares about, there's actually a lot of important people who come from Tatooine. So anyway, we've got this, right? So this is this, and there's a whole bunch, there's more variables, what films they appeared in, what vehicles they've starships they've commanded and vehicles they've driven and stuff. And so anyway, you use select. Select will pick the columns, right? You don't need to put quotes around it. You just say select from the table Star Wars. I want to pick the name, the homeworld, the species, and the films, okay? And so we have Luke Skywalker from Tatooine, a human, and appeared in 5 films, okay? So okay, well, no more spoilers for me. But out of these 7, Luke Skywalker appears in 5 of them. C-3PO out of those 7 appears in 6 of them. R2-D2 appears in all 7. Truly the hero of the entire franchise. So we have that, okay? We've seen the pipe before, and we'll talk about it again. The pipe takes the result of what is in front of the pipe and inserts it as the first argument in the function that comes after the pipe. We saw this when we were dealing with rvest, but basically it says take the output of this and put it into the next function. So if you see x pipe f of y, this is really f of x comma y, okay? So the result over here, x, gets piped into the first argument or the next step. So what we had on the previous slide was select from Star Wars, the columns name, homeworld, species, film. And oftentimes what I will write and what you will often see is Star Wars, pipe that into the function select, and with select name, homeworld, species, films. Okay, and we get the same result as a tibble back. Okay. Keyboard shortcut, while you're using RStudio, to use the pipe, you use Control or Command, Shift, and M, and this will insert pipes, okay? Because it's a bit of a pain having to write % greater than %. So Command, Shift, M will insert pipes. Okay, so let's keep seeing some more examples, right? So as far as select goes, you can say, I want everything but these columns, right? Let's remove the name. Let's remove the eye color. Let's remove the birth year. Okay. And this could be, you know, this could be like some Star Wars trivia game. Who is this, right? Who is gold and has this height, right? None, no sex, but gender is masculine, you know, Tatooine droid. Oh, you go C-3PO, right? Something like that. Okay. But you can do this. Head being like just select the first 3 rows. Okay. You can also use colon notation, and we saw this in when we were dealing with tidyr. Okay. You can just say, I want to select the column name through eye color. Okay. And again, when you're doing select with dplyr, you don't even need to put quotes around the thing. Okay. So we've got name, colon, eye color. And that will select those columns. There's some helper functions that go with select, right? And this is kind of handy. So you can say, I want to select any columns that contain a certain string, or I want to select columns that start with a certain string or ends with a certain string or matches a regular expression. And we'll talk about regular expressions on Wednesday. Or I want to select all the columns, or I want to select some range of numeric range. And this works if if you have columns that are named kind of like X1, X2, X3, X4, sometimes that happens when you have like, when you download like a government data set, you know, the columns just have terrible names and you have to do that. Or you can say one of, and then you basically, you've got a vector with a bunch of names in there, and it's going to select pretty much the columns that are in this named vector, or vector of names, I should say. So here's just a couple examples, right? Select the columns that end with, select the name column, and then the columns that end with color. So we're going to get name, hair color, skin color, eye color. Okay. This is a regular expression. Okay. $$ means the string ends with the S. Okay. Ends with an S. Right. So I could have just done ends with S, but uses, but here I did a regular expression. And this says $$ means S comes at the end of the thing. So we're going to select the name. And these are all the columns that end with S. Mass, species, films, vehicles, starships. Here is a vector with the names in it, column names. We're going to say name, mass, height, and we're going to say select all of the variables in this vector. All right, and we select the columns with the variable names in this vector. I'm going to go ahead and give you your first view quiz answer for today. First view quiz answer today is B. B as in bear. B as in bear is your first view quiz answer for today. B. B as in bear. If you want to select, limit just which rows you're going to select, okay, we use filter, okay? So I should change my language here. Select is for columns, filter is for choosing rows. You're going to filter down to rows, filter rows that meet certain conditions. So here I can say I want to filter down to the only rows, filter the rows where the name matches R2D2. And this just returns one row, and it's the row that has R2D2 as the name. Could you also use select vars instead of select all of vars? I don't think so. I think, let me just, we'll double check here. Versus already loaded. Okay, data. We got that. All right, let's do Star Wars. So we got, let's see, maybe this will work. All right, so here is the vars. From there, we'll select the vars. Oh yeah, it works. Select. Okay, so, oh, it gives you this warning. It says using an external vector in selection. Sorry, let me increase this. So in this case, it says using an external vector in selection is ambiguous. Use all of vars instead of vars to silence this message. So I guess it figures out what you're trying to do and it will do it. It says, see this, and it says this message is displayed once per session. So it doesn't like it, right? So I guess it will do it, but it gives you this message and it says, you should be doing this instead of this. And so here it will do this, but if you just select vars, you get this warning message, or not even a warning, but you just get a message and it says, I don't like what you're doing. Okay, but let's check out what this is. Frequently asked questions. Using an external vector in selections is ambiguous. Ambiguity between columns and external vectors. With select functions like dplyr select, you can refer to variables by name. Okay. All right, I see. This is why it's complaining. So what if I had a vector named, instead of calling this vars, what if this was called mass, right? So now you can see the problem, right? So we can say if I do select mass here, okay, then we get mass versus select all of. Oops. So here we've got this versus this, right? So if your vector name had happened to be one of the column names, calling select on the name of the vector or select is ambiguous. You know, do you mean to do this or do you mean to do this, right? So there is a difference. And so to kind of distinguish when you have a vector of names, they recommend using the all of. Is select better than using Star Wars square bracket vars? So you could also use the square bracket, and that's fine. But yeah, it's let's see. So this will also work. The select function is designed to kind of, so if you have, if it's a very simple case where you've got kind of the variable names and stuff like that, this is fine. But again, if you're going to use dplyr, you might as well start thinking like the way dplyr is designed, where you're going to kind of, where you're going to use the word select, you know, to select your columns. This is fine. This will work. Okay. There's nothing wrong with this. And certainly dplyr might make some of your commands a little bit more wordy, a little bit more verbose. I'm kind of a fan of that though. You know, I know on CampusWire, there's kind of like this game where it's like, write as few lines of code as possible. And it's a fun game, but I'm a fan of just lots of lines, as long as it's clear and you can understand. I write comments all over the place, and that's fine. Obviously, something where it's like you have a very inefficient thing. Oh, this is one thing. You're not going to lose any points, right? But let's say you've got verbose is you've assigned true to it. Okay. You don't need to write if verbose equals true. All right. This is what we call this is redundant, right? You can just do if verbose, right? If verbose, and I feel like obviously if verbose is true, this will be true. But if verbose is true, this is also true. All right. This is I think, in my opinion, easier to read, right? If you just think of verbose as being a switch, as an on or off, and if it's on, you know, you do this, and if it's it's you know, and then you can also you can do something like this, right? If it's not verbose, all right, and this is in my opinion easier than to do like if verbose doesn't equal true or if verbose equals false or something. This is like not great. Right? So you don't need to, if you know this thing is a logical value, all right? Anyway, that's what I'm thinking. All right, filter. So here you can do more stuff, right? If you got multiple conditions, we've got species in, human, human and droid, right? It's going to pick all of the species that are humans and droids, or the characters that are humans and droids. We could say height needs to be less than 175 centimeters. We got all of these people. Filter is very powerful if you pair them up with regular expressions. And I know we haven't covered regular expressions, but we will on Wednesday. And so this regular expression means the thing starts with an F. So we're going to say, give me all the characters whose names start with an F. And I don't know who we have. We have Finn from the new movies. And I don't know who this person is. Finny? Okay. From Coruscant. I don't know a single person from Coruscant. Okay. Dplyr. All right. We can pipe all of these things into each other, right? So we've got this for or. So anyway, I'm going to say, give me people who have no hair color or black eyes. And from there, I want to just select these columns. So we're going to get Darth Vader, no hair color, yellow eyes. Oh, all right. Greedo, hair color is missing. Okay. Because we don't, does he even have hair? I don't know. Okay. And eye colors are has black eyes, okay? And IG88, no hair color, no hair, eye color red. Okay, so this is what we have. Okay, so you can pipe these things. We filtered the rows, then we did the select operation. If you want to put things in descending order, you can use arrange, all right? And then you can put descending order on whatever we have here, right? So we have select rows with arrange, and we have this select these people and arrange, and we're gonna do descending birth year, and then the oldest character. So we've encountered is Yoda, who was born 896 years before Battle of Yavin. And I think this is based on a throwaway line where like Luke is talking to Yoda, and Yoda's like, when you're 900 years old or something. And we're just assuming that this is like happened 4 years after, and therefore, you know, was Yoda exactly 900? Whatever, okay. We can select their based on their position with slice. And we've got this slice rows 5 through 10. So this is like selecting it and or slicing, and we're selecting the rows, picking out the rows. We want rows 5 through 10. What's the difference between select and filter? What does the difference? The difference between select and filter is select is for columns, filter is for rows. Another question: does the order of the functions in the pipe make any difference to the runtime? It does. And sometimes if you put them in the wrong order, things just won't work, right? So let's say you did the select first, okay? That's going to reduce how many columns you have. And so let's say I select based on name, species, homeworld, hair color, eye color, and then I wanted to filter based on gender or something like that, okay? Because if I did Star Wars select and then filter based on gender, the filter won't operate because there's no gender column after I've done the selection. Okay, so if you want to filter on gender, you've got to filter on gender first, while there's still a gender column, and then you can select things, and you don't have to select the gender column anymore, and then this will be what gets returned. So depending on how many columns and stuff and how many, so if you have a major operation and then you do a filter and it filters it down to a smaller number of rows, then your computer can just work with a smaller number of rows and it'll work faster, right? So if you filter down first, so you're only working with a smaller number of rows, and then you do operations, that's going to be faster than having to do a bunch of computations on everything, and then you filter it down to a certain number of rows, right? So there is an effect on the runtime. Okay, we talked about slice. Slice sample is also great. So basically this will select random rows, and this will just kind of get you a small peek. A lot of times we use head, and we'll say like head 10, and this will give you like the first 10 rows. And that's great. But sometimes the first 10 rows will have, you know, something in common, and the later rows are quite different. And if you're only looking at the top few, then you might miss what's happening elsewhere. So if you do a slice sample and you say, give me 10 rows from throughout the table, you might catch a glimpse of something like, oh, we're getting missing values, you know, something is wrong or something like that, right? It's always good after every kind of operation you do, you just take a quick glimpse to make sure you are indeed getting what you want to get, okay? Just, it's like when you're cooking a soup, right? After you add some ingredients, stir it up and take a taste, right? You don't want to just like add like 50 ingredients and then just go like, oh no, something happened, right? Do an operation, check on it. Okay, it looks good. Do another operation, check on it, okay? It's kind of like that. Slice min, slice max, you get like the smallest or the top values. So it's kind of like doing arrange and then calling head, but you can just do it in one thing, right? So slice max, give me the top 3 mass. Okay, so these are the heaviest characters. We've got Jabba the Hutt. I don't know, who is this? I don't know, somebody. Oh, this is oh no, Kali? Oh, never mind. Okay, I thought that's someone else. Grievous? Grievous is super heavy? Oh yeah, he's like that giant robot with the 4 arms. Is that one thing? I don't remember. Okay, it's been a while. Hello there, right? Okay. We can create new variables with mutate. Okay, new variables with mutate. So this will just tack on the new variable at the end. So here I'm going to just say, let's take the height, divide by 2.54, and this will be our height in inches. Okay, height inches. And so if I do this, it just tacks on the new variable here at the very end. And because it's a tibble, it doesn't print out the whole thing. It says you got these more variables over here. So here I'm going to say, all right, give me the thing. And from there, select the height and the height in inches. And we get, okay, Luke Skywalker, 172 centimeters, which is around 5'8", something around there, 5'7.7". Great, okay. Mutate adds an entirely new column, right? So when you use mutate, you need to have a value for every single row in your data set. So whatever you're going to do, it needs to produce a value for every single row. So if you called mean, if you say, hey, I want to calculate the mean, mutate's not the function to use, because if I give 10 numbers to the function mean, it's only going to produce one mean. So that you don't want to use that. Okay. So if you want 10 numbers, you can call something like cumulative mean, and this may or may not be what you want. The cumulative mean is kind of like the running mean, right? It says, you know, C3PO has a mass, or Luke Skywalker has a mass of 77. So what's the mean of the numbers I've seen so far? 77. The first two numbers are 77 and 75. What's the mean of these two numbers? Okay, the mean is 76. 77, 75, and 32. The mean so far is 61.3, and so on and so forth. This is what we have. So these are all kind of what we call window functions. These are functions that are useful for mutate, where if you give it 10 numbers, it's going to spit out 10 numbers. Okay, if you give it 100 numbers, it will spit out 100 numbers, which is what we need, because if you have 100 rows in your data set, you need 100 new values in this column for mean. So P min and P max is element-wise min and max. I'll show you examples of each of these things. You got the cumulative mean, cumulative max, cumulative sum, cumulative product, between, which will, yes, give you back a true false value. Is it between A and B? The cumulative mean, you got lead, lag, and entile. So I've got the cumulative mean. We're going to take a look at the mass and the birth year. And so the cumulative minimum mass is what's the smallest value we've seen so far in mass, right? So I'm just saying cumulative min. So first, the smallest value I've seen so far is 77. The next value is 75. What's the smallest value I've seen so far? 75. Then 32. And then after that, 32 is the smallest value I've seen so far. So that's going to be cumulative min. The ratio is just mass divided by the mean of the mass. Okay. So I'm going to say mean of the mass divided by, ignore anything missing. So mass divided by the mean of mass, this is going to be like, I think the mean of the mass is something like 100, a little less than 190 something. So Darth Vader is, you know, heavier than the average. Luke Skywalker is lighter than the average, things like that. P min is between someone's mass and their birth year, which number is bigger, right? So we do element-wise comparison. 77 versus 19, which one is smaller? P min, 19 is smaller. Between 75 and 112, which one is smaller? 75. Between 32 and 33, which one is smaller? 32. Lag 2 just takes whatever column we have. We're going to take this column mass year P min and basically copy all of the values, but offset by 2. That's what lag 2 does. Or you can do lead, and it will copy all of the things, but shift them up 2 or shift them down 2. And you know, and it's silly to do lag 2 on this data set, but if you've got like some time series data from like you know, the past year, you can do a lag lag 30, and you can compare today's date versus 30 days ago or something like that, or 7 days ago or whatever it might be. Summarize. So what does summarize do? Summarize basically is any kind of summary function. You take like the mean as a summary function. You give it 10 numbers, it boils it down to one number. Variance, summary function. You give it 10 numbers and it boils it down to one number. It gives you the variance of those 10 numbers. Hadley Wickham is from New Zealand, so they spell summarize with an S. Later on, they spelled summarize with a Z. They added that, so you can now use both summarize with an S or summarize with a Z. This came in like a couple years after, and so I'm accustomed to using summarize with an S, and so that I still use it, right? Just kind of like you can use equal sign for assignment in R, but I use the less than dash arrow. And similarly, I still use the S for summarize, but it's fine. So here, I'm going to just say, take everybody in Star Wars. Let's just select height and mass, and then let's calculate these summary values. We want the mean height, the variance of the height, mean of the mass, the min height, max of the mass, and the count. These are all different summary things. So, we had a total of, I think, 87 rows in our data table. And when you call summary on it, it takes all 87 of those values and it just calculates everything that you've asked for, right? The mean mass for all 87 people is 97.3. Okay, and we're using the mean, so it's greatly thrown off by the existence of Jabba the Hutt, who's a huge outlier and really throws off. We know the effect of outliers on the mean. So this is fine. You get one value for the entire table, one summary value for the entire table, but it's really made powerful when you use summarize in conjunction with group by. Oh, let me give you your second view quiz answer. Today's second view quiz answer is E. E as an elephant. E as an elephant is your second view quiz answer. So you use it by group by, and you group it on some categorical variable. In our case, we're going to use species. Categorical variable, and this will create groups. And so we're going to group the humans together, the droids together, I don't know, the whatever alien creature together. Okay, we're gonna group them by species, and then we're going to select these columns. Okay, so when you do group by, it doesn't look like anything happened, right? I said group by species, and I still have 87 rows. It says a tibble 87 by 4. All right, I still have 87 rows, but now I have this little line that says I've got 38 groups. We've grouped it on species, and we've recognized 38 groups. Okay, so now I'm going to do summarize after the group by. So we take the original data set. We're going to group based on the species. After we've done that, then we'll select these columns, and then we will summarize. We'll ask for the mean height and the standard deviation of the height, the mean mass and the standard deviation of the mass. So the species, the Alina species, I have no idea. Okay, the basilisk species, the Syrian. Do you guys know who these things are? Whatever. Okay, droids, we know that. All right, and we counted 6 droids, and this is the mean height of the 6 droids, and this is the standard deviation of the height of the 6 droids. Okay, what did group by do? Group by basically said, oh, we have some droids and we're going to put these two together. We've got some humans and we're going to group the humans together. Okay. If you just do group by itself, it does nothing. It does nothing. But if you use group by with another function like summarize, then it does stuff. So when you do summarize on the whole table, it takes everybody and it turns it into one number, right? You took all 87 numbers and it gives you back one number. Here, we did group by species, and now it gives you summary values. It gives you the mean, but only for each species. Okay, so it says, here's the mean height for the droids that we've encountered. Okay, and this is what we have. All right, so now unfortunately I've got all of these characters where we only had one instance of their species in the table, right? There was only one Ewok in the table that we looked at. So that's it's not that interesting when you say, hey, give me the standard deviation on heights here. Well, it's not going to work, right? So what we can do is, look, this thing gets longer and longer, but I think you can still read it, okay? Especially because we're using pipes. So we're going to say, take Star Wars, group based on species, select these columns, create summary values, right? Summarize, give me the mean height, the standard deviation height, the mean mass, the standard deviation of mass, count, okay? And then from there, which is basically this so far, from here, only give me back where the count of the species is more than one. I'm not interested if we only had one instance here. So we're going to filter, right? So the output of this is this thing where we've got 38 rows, one for each species. And we're going to say, you know what? Just give me the rows where the count is greater than one. And then let's arrange them in descending count. And let's take a look at the first 6 rows, right? So like any other science fiction thing, humans are the most dominant race or species. We've got 35 human characters. We've got 6 droid characters. We have 4 missing species people, I guess. I don't know. 3 Gungans. I don't know. Okay, Jar Jar and the big guy. I don't know. There's another Gungan character apparently named. And so now we have the information here. Okay. And this in the beginning, when you're working with dplyr, seeing something like this can feel a little overwhelming, and it can also feel overwhelming, like, oh, I have to come up with writing this. But again, if you think about this, and again, with a little bit of practice, you'll get better, and you'll be able to read this, and you'll be able to think of things like this. Group by can also be paired with mutate. And so here, let's just look at the humans and droids. We're going to filter out the humans and droids, or people with species is missing, okay? And then we're going to just select those columns, and then I'm going to calculate the z-score for each of these things. I'm going to calculate the z-score for each of these things. And so because I've grouped by species, the z-score is relative to its own species. So we're going to say, calculate the standard deviation of height. We're going to do height minus the mean of height, again, ignoring any missing values. And so Luke Skywalker is 172 centimeters, but he's below average compared to a species of humans. C-3PO is actually shorter than Luke Skywalker with a height of 167, but compared to his own species, he's above average. Okay, so his z-score is positive, whereas Luke Skywalker's z-score is negative, because the calculation of this variable where we calculated the mean and we calculated the standard deviation is done based on the groups here. Does that kind of make sense? It's done, the calculation of these summaries is done based on the groups, and therefore when we calculate a new thing like the z-score, it's based relative to the group. Okay, if we did it without the group by, so I took the exact same line of code, but I just commented out the group by, now it calculates the mean and standard deviation for everybody who's human or droid, okay? And then so Luke Skywalker, who's taller, is slightly above average, and C-3PO, who is shorter, will be slightly below average. So we're going to have a negative z-score here and a positive z-score here. Okay, you can do group bys multiple times. Here is a toy data set where this is just made up numbers. We've got Afghanistan, Brazil, China, country that starts with A, B, and C. And we've got country, year, sex, cases. So cases of some fictional disease here. All right. And we just wrote 1, 2, 3. So we have Afghanistan 1999 female, 1 case, Afghanistan 1999 male, 1 case, Afghanistan 2000 female, 1 case. Okay, so on and so forth. That's our data. We can group by multiple variables. I'm going to group by country and year, country, comma, year. So we're going to group by country and year. And so when I do this, how many cases do we have? Okay, so in Afghanistan 1999, how many cases total do we have? We have 2 cases. In Brazil 1999, how many cases total do we have? We have 2 and 2 make 4 cases. Okay, so when I do this, the summarize will be the sum of the cases. Okay, we're going to create a new column. called cases. And so Afghanistan 99, 2 cases, Afghanistan 2000, total of 2 cases, Brazil 99, total of 4 cases, so on and so forth. So we've created groups based on country and year. Notice the output of this also has another grouping layer. Okay, so we have a total of 6 groups. We have a total of 6 country year groups. And within that, there's 3 more groups based on country, Afghanistan, Brazil, and China. And so I could take this output, which we call summary 1, which is what we have here, and we can further summarize, okay? And when we do that, it will give me the summary for the country. We have Afghanistan with a total of 4, Brazil with a total of 8, and China with a total of 12. So the original data set had 12 rows. When we apply group by on country and year, we get 6 groups. And so the resulting summary table will have 6 rows. But there's still 3 internal groups here. We can summarize on that, and the resulting table has 3 rows. And then if I called summarize on this, there's no more groups here. And so we're just going to get 1 row, right? And it's going to be the total of all the cases, 24. If I change the group by into year, then country, so notice what happens now, okay? It's the same data. I have six rows, but I'm grouping first on year, then by country. So I still have 6 in this summary table, but the internal groups now is year, and I've got 2 groups, a group for 1999, and a group for 2000, okay? And we've arranged it as such this way. 1999 followed by country. And so this is basically this thing just rearranged a little differently. But then if I call summary on this table, summarize on this table, how many rows am I going to get? I'm going to get 2 rows, 1 row for 1999 and 1 row for the year 2000. And if I call summarize on that, again, now all of the groups disappear and we have a total of 48 or 24. Is that okay? This is group by business. Let me give you your last view quiz answer. The last view quiz answer is A. A as in apple. A as in apple. Okay, we're going to run out of time for this 2-table verb stuff. But this is about joining tables. Joining tables. All right, and you'll just have to kind of read this a little bit. Here I've got a people table and a states table. The people, I've got A, B, C, D, Adam, Betty, Carl, Doug. We're pretending they're from California, New York, and Texas. And the states, I've got like the postal abbreviation CANYWA and the full name, California, New York, Washington. And there's intentionally a mismatch. Here I've got Texas, but Texas doesn't exist over here. I've got Washington, but Washington doesn't exist over here. So if you do what's called a left join, we're going to do people left join states, okay? What we're going to do is we're going to include everybody in the people table. There's 4 people. We're going to include all 4 people from the people table. And we're going to just look up, we're going to try to matching the information in the state column, CANYTX, match that with the abbreviation column, right? CA match with CA, NY matches with NY, and we can look up the resulting state name. So we can say, oh, CA stands for California, NY stands for New York. It didn't find a match for Texas, so it gives me back an NA for that one. So that's the left join. The right join is kind of the opposite. We say people right join on states, and with the right join, it's going to give you back all the rows in the states table, the right side table, and only the matching ones on the left side table, okay? So here we have Washington and WA, but there's no person there, okay? And then Doug doesn't exist because we did that, right? The inner join only gives you back rows where there's no NAs, where it finds complete matches. So Doug gets missing, Washington gets thrown out, okay? And then the full join keeps everybody. So Doug from Texas comes in, even though we couldn't figure out what the state name is. Washington with WA comes in, even though we don't find any persons from Washington. All right, so these are just kind of basic examples of how this works. And really the best way is read up on this help page, or this article here and work through the examples. Okay, that will be it for today. We will see you guys on Wednesday, where we cover regular expressions, and we'll see you then. All right, have a good day. See you later.